Hello and good morning, everybody. Thank you for joining us. My name is Jake. I will be the moderator today, but we've got a pleasant surprise for you all, which I'm sure is why you're all here. We've got Don Franklin with Franklin Irrigation Consulting with us today, and we're going to be talking about sports field design, irrigation design. Before we get started, just wanted to touch on a few things. This is going to be recorded, so there's going to be a lot of information. You might want to watch it again. So it will be up on our website a little bit later today, and feel free to go watch that again. We do encourage questions, so please use that Q&A box there for any questions that you guys might have. Even though we haven't started, open it up and start typing in those questions that you might have. Like I said, there's going to be a lot that we cover, but we are going to be doing a couple different, this is a part 1 of 2 at least of a series. So if we don't get to what you're asking, still ask all those questions so that we can get those prepped for later responses and wrapping it up into part 2. Use the chat window for any other banter that you guys would like, but I think I've spent enough time for that. I want to hand this right over to you, Don.
Well, good morning. I seem to be locked up on my screen, Jake.
It always happens.
So
go ahead and exit out of there and try to join it back in.
Let's try this one more time. There we go.
Rocking and rolling.
There we go. Well, we're not going to spend much time on this. Jake has already told you a little bit about me. My job, I've been fortunate over the last 51 years that my job is my hobby. And so since I retired from Hunter, I've, as Jake has mentioned, founded Franklin Irrigation Consulting. So today we're going to be talking about designing for optimum efficiency. We're going to take a look at 4 major items here. We're going to look at head selection, choosing the right rotor for the application. We're going to look at spacing and how to design to get the best distribution uniformity. For some of you, that may be a new term. We'll delve into that more in detail as throughout this webinar. We'll be looking at the effects of wind. I get a lot of questions about wind and head spacing, how far and all that. We'll be talking about that too. And then placing the heads, trying to keep them out of high trafficked areas, mainly for safety reasons. Those high trafficked areas have a tendency to be repaired more often. And so we'll look at some circuiting techniques to allow your sports turf managers to be able to do repairs without overwatering the rest of the field. Before we get into all of this, there are great resources for the geeks and the nerds that are out there. It takes one to know one. The Irrigation Association has some great resources. The Irrigation for 6th edition covers everything from soup to nuts. If any of you are doing any ag projects, they have great ag information. They talk about wiring, pumps, layout, match precip rates. Principles of Irrigation is a textbook to become a certified irrigation designer through the Irrigation Association. And that is an excellent resource. You can get these online, depending on cost, whether you're a member or not. And designing and maintaining piping systems using PVC fittings is a great resource. It's an older book, but the information is still relevant for today. There's also resources out there that don't cost anything. Go to your irrigation manufacturers. They have great resources that don't cost you anything, from micro irrigation clear on up to sports fields. And the handbook of technical irrigation information, that back there, that blue covered one, colored one, that has a lot of really detailed information on wiring and pumps and spacing heads and calculating for mainline size and all that stuff. So those are all available from different manufacturers, and typically they're for free. So let's get right into it. Choosing the right head for the application. The inlet size is really important for sports fields. They typically require at least a 1-inch inlet in order to achieve the proper distances that you're trying to get. These two examples here, the 3/4 inch that you see here, that just does not allow enough water to hit the distances required for sports fields most of the time. That's because the farthest distance that they throw is anywhere between 46 to 48 feet. Whereas with the 1-inch inlet size, well, that can throw much farther. That can throw as far as 70 feet. Now, I'm not recommending that you space your heads at 70 feet apart unless you have enough volume and enough pressure. But the other thing that's really nice about these 1-inch inlets is that they have a stronger retractable spring. And that's extremely important for safety. You do not want the athletes or the children playing on your sports field to be tripping over a rotor pop-up that has been stuck up for whatever reason because of dirt and debris. So it's really, their stronger spring reaction is great for safety. The other options that you have are, do you want to go with a 4-inch or a 6-inch? That really depends upon your turf height. You could use a 4-inch if you wish to in short cropped fields like hybrid Bermuda or something along those lines. But if your sports field has a different type of grass that typically grows longer, then you're going to want to think about moving to a 6-inch. I know it's going to be more expensive, but there are a lot of positives moving to a 6-inch over a 4-inch, particularly if you are working with public agencies. I would always use a 6-inch rotor, regardless of the field that is going in. And that's simply because public agencies typically, their resources have been strapped. They don't get around to mowing every week. They might get around to mowing once every 2 weeks. And in some cases where I live, it's been once a month mowing. And so a 6-inch pop-up height ensures that it'll pop up over the top of the grass and you won't get dry spots. There are other options out there for you. You can use dual opposing nozzles or a single nozzle. Dual opposing nozzles are really for a 360-degree pattern. The single nozzle can also be for a 360-degree pattern, but it's also used for quarters and halves. Now you can mix both of these on your field. And in fact, you'll have to, if you decide you want to use an opposing nozzle, you'll have to use a single nozzle when you're designing for replacing heads at 180 degrees or so. So you can use them on the same field. You typically, which we'll get into a little bit more, you may want to separate your folds from your part circles, but we'll cover that in a little bit. You also have an option. Do I go stainless steel riser or do I go plastic? Stainless steel risers are typically more expensive, but they're really good in areas where you have a lot of grit and sand. If these heads are just a little bit below grade, the stainless steel will last longer. It doesn't get scarred as it's popping up and down from the soil. So those are options that you can that are available to you. They are more expensive. And so if you want to go with a 6-inch plastic, because of cost reasons, that's okay too. And the last option that is available is a turf cup. And you can kind of see that down here in the lower left-hand corner. And this little guy here looks like he's got a crew cut here. These turf cups are really useful if the heads are buried. particularly in professional fields, just simply because when somebody is running down the field, you don't want them to step in a small hole where the rotor might be. And so a lot of times turf cups will be incorporated. Some of these larger rotors down here in the lower left-hand side, they can be used in synthetic fields as well. Turf cups are great if you're going to be using these rotors in synthetic fields. Rotors have been gear driven. The plastic rotors have been gear driven for decades. And this is a standard gear driven rotor. Now you can see that the water is going to come up through the basket underneath here. And then it's going to turn a little impeller here, turn some gears, and it's then going to turn what we call the turret, which is at the top where the nozzle is actually housed. And they have been around for years. But like computers and smartphones, technology has moved on in the field of rotor development. And planetary gear, even though that's not a new technology, it is a new technology for our industry. And that design is being incorporated into rotors, and it has some great advantages. It's great where you have poor water quality. If you're pulling out of a lake or any kind of raw water out of a ditch or something like that, this thing just does not stop. The way that it is designed, it is specifically designed for poor water quality and also for softball field infields. So these just do not plug up, they do not stop. When I worked at Hunter, we had some guys that tried to stop the turret with their hands and tried to strip it. They couldn't do it. That thing kept turning. And a lot of the manufacturers today in the standard and in the planetary gear drive rotors, they have incorporated what they call smart arc return or something along those lines, so that if vandals come and they twist the turret, in the past, that would ruin the rotor. Today, there's technology in both the standard and the planetary gear, which allows it to return to its original arc. You want to make sure that you have correct pressure for the desired radius that you want to go. And so when you're looking at these performance charts, I would recommend that you try to stay in the middle. So in this number 15 nozzle, it will operate well within a 50 to an 80 PSI range with various distances. I would recommend that you not design to that lower side for a couple of reasons. Number one, the distribution uniformity, which we'll talk about in more detail here shortly, is not quite as good. And the other reason is that as systems age, which we'll be talking about here shortly, if you design to that lower end and pressures drop below 50 PSI for whatever reason, then there's going to be some problems out there. So I'd highly recommend that you try to stay right in the middle of your pressure ranges in there. You want to make sure that your heads are evenly spaced throughout your sports field. This will give you the best opportunity for a higher distribution uniformity. And then how far should you space your heads? Well, you have some variables out there that you don't always have control over. Wind, the speed and the direction, and also trying to keep them out of high trafficked areas, which I mentioned before, because those high trafficked areas are going to have excessive wear and need to be repaired more frequently. So once you have chosen the correct nozzle, just try to stay again within the middle of the pressure ratings that are for that particular nozzle. And before I leave this slide, there are times where people will say, well, maybe I could go with the number 23 nozzle, which you see down here at 60 PSI, and it'll throw 62 feet. The problem is that now you're on the lower end again. And if pressures change, then you may end up with some dry spots. So just always try, whichever nozzle you choose, always try to stay in the middle. I think most of you have seen this type of pattern before. We call them donuts. Some people call them crop circles. And so the question is, what causes these? Hopefully this doesn't happen when you have done your design right out of the chute. This typically is a problem that shows up after years. And so the problems that typically arise from this, or that cause this, are low pressure. And low pressure can be caused by maintenance changes. So the maintenance personnel may not necessarily understand hydraulics, and they've got a dry spot. So what they'll do is they go, oh, I've got bigger nozzle, so I will put a bigger nozzle in here to get more water so that my dry spot turns green. So they may put in several larger nozzles. But what happens is that when the flow goes up, the gallons per minute goes up, the pressure drops. And so then they might put in some more larger nozzles. And as they do this, again, the flow continues to go up, the pressure is going to drop, and now you have these donuts or these crop circles. Another reason for low pressure is a higher demand on the domestic water supply. And that's because new homes are going in. You have new shopping centers, new schools, new parks. Where I live in the greater Sacramento area, this has been an ongoing problem. The pressure has literally been dropping because of new construction going in. That's the other reason that you don't want to choose, again, in that previous slide, you don't want to be on the low end of your pressures. And then water agencies will drop pressures. Water conservation has been huge across the Sunbelt states. Water agencies get their revenue by selling us water. Well, when we are conserving water, then their revenues start to go down. So they have to look at ways of bringing their overhead down. And they will do that by reducing the pressure in the domestic system. And when they do that, their electrical or energy costs will go down. Another cause of these donuts is poor spacing. When you get a design build contractor who's really concerned about bringing dollars to his bottom line, he'll put in as few heads as he possibly can and as few valves as he possibly can. And so you can get this by poor spacing as well. And then finally, incorrect screw adjustment on the rotor itself. All rotors have this little screw in it that holds the nozzle in, but it can also be used to adjust the radius. And typically that is about 25% of the throw at a specific pressure. That's the maximum that you can reduce that down. But I've seen a lot of times where contractors or maintenance people have just screwed that down so far that it really fans out the spray. And so you can get donuts that way. And they do that to try to irrigate these dry areas that you see in and around here. You know, their logic isn't flawed. It's just not the right solution for that problem. I'm always asked from time to time, you know, which is best? Square spacing, rectangular spacing, triangular spacing? What is really the best? And it really kind of depends on the landscape architect or the irrigation consultant. Some landscape architects like triangular spacing best for any given area. And the reason for that is just simply because you'll use less heads. So it's a cost savings design. But when you're working with what I call wonky fields, like a baseball field or an Australian football field, you know, the square spacing, rectangular or triangular spacing, sometimes you'll have both of them. So in this example here we have square spacing. Right next to it, we have triangular spacing. And as you look at some of these heads here, You even have trapezoid spacing on this. So the best rule of thumb is to just use the pattern that best fits the area. And it is not uncommon, and it's not incorrect, to have both square spacing and triangular spacing in the same sports field. Jake, do we have any questions or anything?
We do not have any questions. I want to remind you guys to ask questions. I'm intrigued in all of this, so I've just been sitting watching. But if you got anything, definitely bring it to us. I just want to chime in on this one because this has always been one of those things that, as you look at even the performance charts in the books, it's not just cut and dry, right?
Right.
The manufacturer is saying this is your precip rate, but it's literally based on a very perfect set thing, which this design obviously isn't. So it just shows that whole ebb and flow of proper spacing and proper layout to get what you need, but it doesn't necessarily translate to even that precip rate too. So just always found that interesting.
Mm-hmm. So let's see what we can do to get the highest distribution uniformity. There's kind of a cardinal rule that you never use the manufacturer's published radiuses. And the reason for that is that those radiuses that they have are all based on zero wind conditions. That is the only way that they can really determine what the precip rate is. And it goes back to what Jake just said. You can see on this that you've got square spacing and triangular spacing, and the precip rate is a little different. Please do not ever space your radiuses at manufacturers' published data. They're all in zero wind. Contractors will ask me, well, why don't they publish information for windy conditions? Well, that's a variable they can't control. Okay, so we choose a 5 mile an hour wind. Well, is that coming directly into the head, behind the head, on the side of the head? So they just can't really give good solid information for wind conditions. And we'll look at some of those. And so you can see how to actually design for windy areas. So typically, as I had mentioned before, you want to stay right in the middle. For the best distribution uniformity, you want to stay right in the middle of a specific nozzle's pressure range. That will give you the best distribution uniformities. And the nice thing about high distribution uniformities is that your energy costs will go down if you have a booster pump. Your watering windows will shrink. And sports turf managers, they don't have, a lot of times, they don't have 10 to 12 hours to irrigate. In some of the professional fields, particularly when they're doing multiple events, they may have to get that entire field irrigated in 4 hours, ready for the next event. So always choose pressures that are right about in the middle, which will help lower your energy costs, and it will shorten your run times and give you a much smaller watering window. And as a general rule, I know many of you have kind of been thinking, okay, so how far should we space these heads? As a general rule, when winds are not very heavy, anywhere between 80 to 95%. So in this particular case, choosing a number 15 nozzle at 70 PSI, it's going to throw 57 feet. If you space it at 85%, then it should be installed at approximately 48 feet apart. That ensures that you get good head-to-head coverage, and that if there is some wind, that you'll won't develop dry spots. This is what we call a densogram. This program was Space Pro was developed by the Center for Irrigation Technology down at Fresno State in California. It's a great tool. The software does cost. It will not run on Windows 10, unfortunately. It's very, very old software. It was developed in late 1980s or 1990s, I believe. But what's really nice about creating these densograms is that Fresno State puts these rotors into a huge area with about 200 cups, and they're catching water droplets. And in this densogram, you can see that the driest areas here are light, and the dark areas here are where they have more water. And as these cups are catching the water, they're sending the data to a computer. The computer crunches all of these numbers, and it comes up with a distribution uniformity. And on this one, it's 90%. That's really nice, because now we strive to be at 100%, but nothing is perfect. Nothing is at 100%. But you can design sports fields to where they're in the high 80s or even into the low 90s. And this tells me right now that I have a 90% distribution uniformity. That would be great. It also tells me that my precipitation rate or application rate is a little more than ½ an inch. And then over here, it gives me a scheduling coefficient. And what that number tells me is that if I had to get at 100% coverage, I needed to irrigate for 45 minutes. I would take that scheduling coefficient and I would multiply 1.1 times 45 minutes, which would give me approximately about 50 minutes. So I'd have to run it longer. So the smaller that this distribution number is, then the longer your runtime is going to be to get enough water to the driest areas. I've created down here on the lower left-hand side, this is really more for my use, that I've created a spreadsheet that for these two particular products, with a 28 nozzle throwing at 72 feet and a 25 nozzle and a radius at 68 feet at 80 PSI. So I've keyed in 80 PSI. This is the distances based on the manufacturer. So I'm now using my Space Pro program to space these heads out at these different percentages along here, which then it gives me the proper distribution, or the proper DU. And then down here below, it gives me the distances. So when I'm designing, I'm going to try to be right in this area right here, between 65 and 62 feet. Now, that's also going to depend upon how big my sports field is. A rectangle, a football field, or even a soccer field, it's pretty easy to be able to stay within those distances. But if I'm doing a baseball field, that I may have to, in order to make everything even, I may have to be somewhere in this area here, maybe to an 80 to an 85%. But that's what Space Pro will do, is it'll help guide you to determine the best spacing for the highest distribution uniformity. LandFX has a really cool tool. I'm new to LandFX. And in full disclosure, I am a convert to LandFX. I was one of those snobby guys that would say, oh, you don't need design tools. You just place your heads and you do all your calculations by hand and everything else. Well, I sat in on one of the seminars and saw some of the things that LandFX can do. And one of their really cool features is this uniformity feature. If you have not used it, I would highly recommend it. Jake has webinars on this. And as you can tell by the legend down here, the blue is a single coverage. Green is 2-head coverage, which is what you strive to get, head-to-head coverage. 3-head coverage is better. So this typically would be maybe from a design build contractor that used manufacturers recommendations, and they used 19 heads and 8 valves. And so they can put more money in their pocket. But what you can see is that you've got these single head covered areas, which could then develop into dry spots and into those donuts that we saw earlier. Conversely, if you then shorten up the radiuses to about 85%, you're going to end up adding about a third more to your material costs. It's not, in my opinion, that's not that much, because when you put in more product, you're doing your client a favor, because the ongoing maintenance costs to that, they will have less dry areas. They'll be able to shorten their watering windows. If they're using a pump on this, then their energy costs will go down. So putting in more heads might cost a little more on the upfront costs, but on the long term and the maintenance costs, they will be much, much lower. And you will give your sports turf managers a lot more flexibility on irrigating shady areas versus sunny areas and so forth. So let's take a look at a typical football field that we have. And if you don't have any strong wind situations where just light wind occurs, and you're always going to have wind, then you can actually go through and space your heads out at about 90%. So what we've done here is that we've taken a number 25 nozzle, and we're using that at 80 PSI. The radius is going to be 68 feet, but I want to put that at about 90% based on the information that I have gathered. 90% will give me a good DU, 90% of the radius, and I'll have good head-to-head coverage. So that means that my heads will actually come in at about 62 feet apart. Then we want to take a look at the row spacing on this as well. And so when I'm going into my full head with this opposing nozzle, I'm still at 80 PSI, but that nozzle is a little bit bigger and it's going to throw a little bit farther. But I still want to keep it based on the information that I have gathered. 90% is going to be the sweet spot for this. And so I just take 0.9, multiply it times 72, and my spacing then would, my row spacing would then be 65 feet. So we're not really square. We're kind of more of a rectangle in this particular. But I also want to bring your attention down to this guy down here. All of a sudden, now I've got a triangle down here in the end zone. So why did I do that? Well, that's because these nozzles here would not get me far enough out here. So I had to put a small full in here to accommodate for the end zone.
Hey,
so
Don.
again, yes.
With this specific point right here, we actually did have a question on a previous slide that I don't think you need to go back to, but it was along the same lines, where what was your logic behind the 15 nozzles be behind or near the left and right foul lines? So I'm assuming it's going to be the same thing, right? Where they just
Yes,
don't reach those additional
that's
nozzles.
correct. Yes,
Cool.
that's exactly correct. And so you can still put in, different size nozzles. We'll talk about full part circle circuiting here in a couple of slides, but you can still put in those smaller nozzles and still even have them on the same valve, as long as their patterns are somewhat the same. Meaning you're going to have part circles. You might have, and I think we even have it on this one, that I have 25 here and I have 15 here. And that's so that I can get the coverage that I need. If I had put a 25 back in here, Jake, it wouldn't have covered, it wouldn't give me the coverage that I needed in between these two 25s. So I hope that makes sense.
Perfect.
So let's talk a little bit about wind. And there are times where you may even have to, in windy areas where you just have wind almost 24 hours a day, that you're going to have to really shorten up those radiuses. Maybe go as close as 50%. And so where do you find this information? Here in California, we have the luxury of having what we call CIMMYS, California Irrigation Management Information System. It's a backbone of weather stations all up and down the state of California. Not everybody has this, but I can go in there and determine what the wind is for any given month, day, or even hour in the CIMMYS network. So that's typically where any of you that are listening to this in California, I would encourage you to go to CIMMYS. Those of you that are not in California, I found that NOAA has some really, really cool information that's out there. And you can get this based on the country that you live in. You can get it based on the US territory, but mainly in the state, down to the county level, and even down to the zip code level. This is very, very cool. And so I went and looked at the city of Modesto, which is in the Central California area, at their airport. And I brought up one of the reports, and I want to draw your attention to this wind speed area here that's highlighted in yellow. And this is the report that came up. And you can see that they give you the average wind speed. They give you the peak wind speed. And I'm typically asked, so which would I design to you? I would go to the average wind speed. I'm not necessarily designed to the peak wind speed because that's going to be momentary. And then they give you the direction in degrees. So if you have your smartphone, we can see that the wind direction coming into the airport is typically, north by northwest or something along those lines. So you can get that information from NOAA. Going back to our CIMMYS network here in California, what's really cool about that is, yes, it will give me the average wind speed. It'll give me the minimum and the maximum as well, but I choose the average. And it also gives me ET information, which is great for scheduling. And it can give it to me on a daily basis. I've chosen the month of June on this one. You may want to look at all months or at least the hottest time of the year. So that could be June, July, or August, depending on where you are. And so it shows me my average wind speed. And one of the things that you can do to help mitigate is to wind effects on your irrigation system is to run your irrigation system during non-windy hours, if you will. And that could be, in the middle of the night. It could be early in the morning. I'm not sure. It depends on your area. But that's one of the ways that you can help to work around wind issues. And then you want to make sure that you have the sufficient water volume, the gallons per minute, and the spacing. And in this case, I've used large nozzles on this, but I have always made sure that I am in the middle range of my pressures down here, the 70 to 80 PSI range, that if you're going to start, if you have some real wind prone areas, then you want to make sure that you go to a larger nozzle and make sure that you have the pressure to be able to push that water and have it punch through the wind. So in areas where you do have a prominent wind direction and wind occurs regularly and you just can't seem to get around it, then spacing is going to have to be shortened quite a bit. And so what we've done here is that we have looked at about an 80% spacing on this particular drawing. It's a little different than the football. It's the same football field, but it is a little different because it is in a windy area. And so I actually have more heads in this particular design than what I had in the previous one because I'm going to an 80%. And so when you look at the number 25 nozzle at 80 psi, I'm going 80% of that 68 feet based on manufacturer's radiuses. And so that is actually coming up to 55 feet. So my row spacing now is at 55 feet. But my wind is also coming in at a specific direction. And so on my fulls, on my opposing nozzles, which were 72 feet, I have shortened those guys. Instead of at 80%, I've gone to 70% because the wind is coming right across those heads. And so I've spaced those heads out at 50 feet. So you can see even in this pattern here between the edges and the fulls, that's actually triangular. Going back to, you could use both. And then in the center of the field, there's square spacing. Any thoughts or questions?
Not right now. That is perfect, though.
All right, so let's take a look at a field. This is actually a local field at UC Davis. It's their soccer field. I worked with their sports turf manager and their maintenance supervisor on this particular project. And we're going to take a look at circuiting. And what we want to do is to group heads together that have the same characteristics. And what I mean by that is that you want to take and put full circles on their own circuit. Please do not mix full and part circles. I know that manufacturers will say they have matched precipitation rates on some of their nozzles. That's only good for a specific distance. When you start getting out to 50 feet or more, you're not going to have matched precipitation rate nozzles. It's extremely hard to develop. It's a lot easier to just circuit your fulls by themselves, circuit your part circles or your halves by themselves. And a lot of designers don't do this. I put my quarters on their own valve and their own circuit. And that's because of the amount of water that these heads are throwing out. I want to make sure that my sports turf manager has all the tools that he needs in his toolbox to properly manage his sports field so that he can put more water in his dry areas and less water in his wet areas. When you're mixing quarter heads and half heads here, and you put them on the same valve, this quarter head is literally putting out twice the amount of water as this half head is in a given area. And that's because the gallons per minute are the same. These are both number 15 nozzles. So they're going to put out, say, 15 gallons per minute. This is putting out 15 gallons per minute in this quarter area. This is putting out 15 gallons per minute in this half area. So this area could be potentially a swamp, but if you separate them, then you can control the amount of water that goes into a specific area.
Hey, Don.
Yes, sir.
I wanted to touch on that one too, just really quick. You said that if you've got, the match precip nozzles, or you do it where you're using maybe a nozzle set that doesn't have necessarily match precip, but you are putting in the nozzles to account for the quarter, half, and full differences. I've seen a lot of people do that. I used to even do that in some respect on smaller scale. But I would even say, think about that from the standpoint of, yeah, that you might be doing it properly there so that you could mix them. But think about it at that worst case scenario. What happens when that maintenance guy goes and changes out that quarter to a larger nozzle?
Exactly.
Or something like that. So you basically are setting up a fail safe if you're zoning these properly, putting the quarters on quarters only, halves on halves. That way you can, if you need to, still put the right nozzle in there if you wanted to keep it at a smaller nozzle, but you also then are just protecting yourself once somebody does change something or something in the design changes and it messes that, initial thing up. So
Yeah, you're absolutely correct. The rule of thumb, and I would say probably rule number one, is that your projects need every opportunity to succeed. And by circuiting them this way, you are giving that project every opportunity to succeed, even if somebody comes in that doesn't know about hydraulics and it starts changing nozzles out. So you're absolutely correct, Jake. Thank you. So let's take a look at high trafficked areas. Again, this is the same field. And in talking to the sports turf manager, this is where we placed our heads. He wanted to make sure that heads were not in specific locations, mainly because that he has to repair those areas and also for the safety of the students there at UC Davis. So we wanted to keep the heads out of high played areas or high trafficked areas. So we wanted to keep them out of the center field, and we wanted to keep them out of the goal areas where there is a lot of activity that's going on down in through here, down in here in the center area. I have seen sports field designs where they'll put, a sprinkler head right there in the center of that thing. That's not a good place for a sprinkler head, and it's not good for the players. And we also want to group or circuit our heads together based on repairs. So a lot of times, the repairs are going to be done in and around the goal area, and they will probably be done in and around the center area as well. So you want to make sure that you circuit those separately and that you keep those heads as much as possible out of those high trafficked areas. So let's tie it all together and do review. We're coming up on almost 10 minutes till. I'm not sure on questions that people may have.
yeah, we've got some that we'll handle after you.
Okay, great. Well, we'll just kind of blow through this in that when you're selecting the correct rotor for your application, choose your manufacturer, either your choice or your client's choice. Do you want to go with a 4-inch, which might be less expensive, but a 6-inch really would be better? You might have to talk to your client about that and say, look, it's not going to add that much more cost, maybe 10% more to your project if you go with the 6-inch because of the type of grass that you're growing.
Hey, Don.
Uh-huh.
With this specific item, Jason's actually asking, do you have trouble finding 6-inch rotor heads? Because it seems like manufacturers have a 5-inch and a 4-inch in those larger radiuses. So
yeah, it's going to be, the short answer is no. I would look in their catalog. It depends on the manufacturer. When they say a 4-inch or a 6-inch, that is a general term that the manufacturers will use. The actual pop-up height riser for a 4-inch is going to be probably about 3¼ inches. And maybe for a 6-inch, it's going to be more like about 5¾ of an inch or something along those lines. So when I'm using terms such as 4-inch and 6-inch, those are kind of generic terms. They even have rotors, not for sports fields, but for native areas that are 12-inch pop-ups. So those rotors are out there, not necessarily conducive to sports fields. So he shouldn't have a problem. I would have him check with his, manufacturer.
perfect.
Stainless steel or plastic. Stainless steel, you may want to use that, for softball infield, where you're wanting to water down brick dust or something along those lines. And if you are using a rotor for something like that, I would really recommend you use something with a planetary gear, so it doesn't stop turning. And then single nozzle or dual nozzles, you can use both. on a specific sports field. Dual nozzles really have some really nice distribution uniformities. So use those, I would recommend, in your full circles where you can, if your manufacturer offers those. And then just make sure that you're choosing the right nozzle for the correct pressure and the radius. Pattern wise, use the best pattern that fits the area. It's that simple. So there is no one size fits all, square, triangular. They both work well. And then as a general rule on head spacing, you're going to want to be anywhere between 80 to 95%. In windier areas, you may need to shorten those up as close as 50%. In some of the areas here in the Northern California, we've got winds that are just 24/7, and we've had to shorten them up 50% of the radius. I can't emphasize enough, not because this is a LandFX webinar, but they have some really cool tools. And that uniformity feature is awesome. It'll tell you very, very quickly whether or not you're going to have dry spots. It's a lot easier to fix the problem when it's digital, as opposed to trying to start moving heads and adding valves when the system is going in. Check your project using NOAA for wind speed and wind direction, or if you're in California, use CIMAS, has a lot of good information. And again, you may have to shorten those radiuses up as much as 50%. And make sure that you put your heads on separate, your full circles and your part circles on separate valves. Keep them separate. You can match precipitation rates when you do that. So I can have a matched precip rate on a full circle, and I can take that precip rate and match it to a half. And the way that you do that is by adjusting the irrigation controller, the runtime. So if I need to put 30 minutes down for a half, then I'd have to put 60 minutes down for a full. It's really simple, gives your sports turf manager a lot of flexibility when you do that. And try to group your heads in areas where you have a lot of repairs. You try to circuit those guys together so that in those high trafficked areas, so that when they are putting down new sod or reseeding, they can irrigate only those areas without having to put more water in areas that don't need it. So I think that's just about it, Mr. Lott.
Yeah, we've got a couple questions that actually pertain to number 5 and 6 here.
Okay.
Patrick is kind of reiterating or asking this again, but about the quarters on a zone, grouping those together, and really specifically, do you put all quarters on a zone? Because it seems like that might be excessive from a lateral perspective. I'll give my point of view on it, and then you're free to tell him stuff. But basically, it really comes down to the site, maybe the cost constraints, everything about it. But if it is going to be an excessive run for laterals, you might be trying to get some X amount of flow, and it's increasing the pipe sizes, and it's not worth it. So it's okay to put another valve, but obviously if you're doing only 1 or 2 heads on a zone and there's a ton of locations, it might increase your costs. So you got to be smart about what you're trying to circuit together, but anything and everything between would be acceptable in my mind.
Yeah, I would agree. Down at Petco Park, the irrigation consultant that did that project did a great job. And not only did he give the sports turf manager micro management capabilities, but he also looked at the sun and shade exposures and how shade moves across a baseball field as the sun is moving. And so he gave his sports turf manager the ability to apply less water to those areas that required more shade at a specific time of the year.
Yeah.
And so those are
considerations.
Yeah. And so to answer the question is, Yeah, try to design the system to where if you had to manage it yourself, what are the things that you would like to be able to do to this system after it's installed? How do you want to manage it?
Yep. And that actually pours right into this follow-up question he had, which is, if you had back-to-back fields, would you be able to connect the quarters on two different fields? I'm going to say that's a straight up no.
Yeah, I would
Because
agree.
you've got to, from a flexibility standpoint, managing standpoint, maintenance standpoint, you know that this field's coming on. It's not going to be, if that one field has to be discontinued for some reason for maintenance or whatever, that it's not tied on to another zone. So keep everything separate, zone
Yeah,
it properly.
yeah, exactly. And remember that, you know, sports fields today are getting so much more use than when I was a kid. And that was like 50 years ago, or well, all right, a little farther back than that. But anyway, where I'm going with this is that um, sports fields have a lot of heavy use to them. And a lot of them are going in synthetic, which is fine in some areas to take pressure off of the natural fields. But where they're putting in natural fields, your sports turf managers have to have time to be able to allow those fields to recover. And so for that reason, you don't want to tie things together on different fields, just like you had said, Jake. You want to give them as much flexibility and as many tools in their toolbox that you can give them so they can have uh, a, a successful field.
Yeah. And without overwhelming them.
Right.
So, John, we got a few more here that keep coming in, so we got a few more minutes. John is actually mentioning from the number 6 point there, keeping heads out of high trafficked areas. They actually usually provide a safe zone around soccer, so
Oh,
probably
yeah.
like a 10-foot deal. So he's asking, do you always irrigate right on the sidelines and end lines? Is that pretty typical, or?
Yeah, no, where you have these safety zones and whatnot, where they're, I would irrigate those separately. If you know that those areas are going to be there, I would put them on because there is so much foot traffic that is going on there, even though they're on the edges, on the peripheral. You definitely want to valve those differently so that the sports turf manager can go in and either resod or reseed or do any kind of repairs, um, necessary to keep those safe. It's all about player safety when you're designing these fields.
Yeah. Last question, and then we can go to our last little teaser slide. But Anne's wondering, and this is a great question, it kind of hits home on all this stuff, is if you have a 15 full head, like at the end of that football field, do you zone it with the 25 full head, or does it need to be its own valve?
Well, that is a great question. I would look at the precipitation rates on those. So if the precipitation rates on both for this area that they're covering, the precip rate is the same, you can put them on the same valve. But if the precip rates are different, then I have seen sports fields where the irrigation consultants will put one head on one valve. And they have a reason for doing that. Maybe it has a higher precip rate or something along those lines, or maybe that area has a lot of high traffic area in it and they have to repair it frequently. But I would look at the manufacturer's information, and if they have the same precipitation rate, then yeah, you could put them on the same zone.
Yep. And just knowing right off the bat that if they don't match and you put it on there, you can expect something not to be either overwatered or underwatered. It's just
Right.
literally hydraulics 101 on that from that point
Yep.
on. So I think we go to the next slide. No more questions. So thank you guys for those.
So in part two, We're going to be talking about velocities, pipe sizing, pipe layout, and possibly some scheduling considerations. In the pipe sizing, you should be able, we were thinking about putting that in this one, but we just didn't have enough time. You should be able to determine and we have calculations that will show you based on the area that you have and based on the weather information for the hottest time of the year, you can actually calculate what your main line's pipe size should be without ever dropping in any kind of pipe at all. Even without a meter, you can calculate the water requirements at the hottest time of the year based on weather. So there are calculations that are out there. We'll be talking about velocities. We'll be talking about the various rules in velocities that they may change depending on your project. So we'll be delving into all of that in part 2.
Cool. Well, I think we have spent our time. Don, thank you so much. This was great. People really, really loved it, loved the content.
I hope it's useful.
If you guys have any questions past this, feel free to reach out to us and we can pass things along. And have a great weekend, everybody.